So a little bit about me. I'm a red team lead at General Motors, responsible for logical physical assessments, penetration testing, and red teaming globally. I've got a few certs there that you all are probably familiar with, and that's my Twitter handle if anybody cares to follow.
Yeah, and my name is Kyle Cucci. I go by Kyle Cucci, Kyle Cucci, Kyle Cucci. The last one is not the suggested version. I'm a security researcher at a large unnamed automotive supplier, and my responsibilities are basically security research for making automotive systems safer and more secure. And yeah, thanks everybody for being here, and we hope you enjoy this talk.
All right, so for our agenda, we're going to start by getting level setting with some terms, definitions, acronyms. So if people are not familiar with the red teaming side, or if people aren't familiar with the manufacturing side, we kind of level set before starting. Then we'll go into why red teaming in a manufacturing environment is important, and a little introduction into what a manufacturing environment and network look like, some potential methodologies you could use. We'll go into a step-by-step with a couple of attack vectors of a red teaming assessment, some lessons learned, common findings, and mitigation measures. So our goal for this talk really is two goals here. To motivate organizations to do red teaming manufacturing assessments if they have them within their organization, and also shed some light on some common issues, maybe for better awareness for defenders and for management on what these common issues are and how they can be mitigated. So a couple of terms here. Red teaming is not penetration testing. I know there's a lot of talks on penetration testing and red teaming, so we thought we'd give our terms here. So penetration test, really the objective is to find all of the vulnerabilities. So let's say it's a penetration test against a website. Find all the vulnerabilities, cross-site scripting, SQL injection on that one website. Write up a report, exploit them, and show, here everything wrong with your system. On the other side, red teaming is more of objective goal-driven. So maybe the objective is to break into set box, and that's the main objective. How you get there, how many vulnerabilities you exploit and find along the way is less important. A couple of the industrial cybersecurity and industrial terms. So ICS, Industrial Control System, here we're going to use that as more of a generic term that includes all of those industrial devices, embedded devices. If you go out and read the manufacturing, environment, networks, and resources that we have listed at the end, there's a lot of other acronyms, but right now we're grouping them for simplicity into ICS. We have PLCs, Programmed Logic Controllers. Those are what execute on the manufacturing network, control network, which we'll show in a bit. And HMI, which is a human interface, so a visual representation of how to control and configure some of those systems on the control network. So why red team manufacture facilities? Attacks on manufacturing can inflict, quite a lot of damage. There's been more than a few recent vulnerabilities that have been exploited in manufacturing, along with specific malware like WannaCry, Havix, Triton, Stuxnet especially. Stuxnet is especially complicated and, large impact from what Stuxnet had and shed a lot of light into the manufacturing environment. Red teaming can help an organization get a real assessment on how their organization security posture actually is. So let's say you run a vulnerability scanner, you're doing some of those other layers of security before going out to red teaming or penetration testing. You're going to find vulnerabilities. You may not find how they're connected or what the true impact on the organization and network is. To do that, you would need something like penetration testing and then even more so red teaming, right? So how do these vulnerabilities work? What is their true risk to the organization? And how can they be exploited and used by an attacker, an adversary, to get a foothold into your network and complete their objectives? So instead of you have cross-site scripting or you have SQLi, it's more of a chain of events that would lead to what could happen if those were exploited. Quick introduction into manufacturing networks. So the top layer we have here is the internet, right? Everybody's familiar with that. We got some users on the outside, got a firewall coming into the network. The next layer we have here is the office IT network. That's going to look like any other organization's network. You know, you have printers maybe, you have normal servers, clients, people are doing work in the office. This is the network which they reside. Next, we have a supervisory network. This is more manufacturing, industrial security specific. There's different acronyms that you may see going across different types of references here. It's pretty standard with supervisory. You may hear DMZ, as in DMC from Office to Control Network. There's the control network. That's where the magic happens. That's where, you know, machines, computers meet the physical world and are creating processes or actions that are producing something, manufacturing something. So we have the machines, maybe some HMIs on the left, those robots, physical robots, acting on a process, completing a task. So to define what kind of devices are in this network, as I covered, we have the business servers, the client servers there in the Office IT network. We're all familiar with that. Some supervisory systems and what's called historians on the supervisory network. Configuration databases for the control network devices. How are those configured? What are the specifications? All those details that keep those machines running and doing their job effectively. We have PLCs, HMIs, and then we have the actual manufacturing machinery. So potential methodology for red teaming in manufacturing. Like penetration testing or red teaming anywhere else, you have a scope. A scope we think is very important within manufacturing. If you take a look at, you know, your environment within your organization, are you going to take a look at a single manufacturing facility? Are you going to go broader out and look at the entire infrastructure of the network, entire physical infrastructure of a specific facility? You know, logical, physical, all those determine the scope. How broad are you going to look? What is your focus? What do you want to focus on? So constraints, how do you communicate the testing to the facility, the people within the facility? Are they going to be aware of it? You know, typically in red teaming, they're not aware. It's testing active defenses, testing, for instance, your monitoring capability and maybe your physical security guards. Are they following the processes that you believe are in place? In a manufacturing environment, availability is key. Also with, of course, the other CIA triad, but availability is important. These devices are making something, making typically a product for the company, so you don't want to interrupt that product being made. You want to do your assessment, but don't have any negative side effects on your organization. Also, we put here no mass scanning tools. If you're new to this, it's best to learn the manual methods before moving on to the scanning tools. A lot of the scanning tools are very aggressive, and some of this devices within the control network may not play so well with some of these automated scanners that look for everything, you know, against devices here. So you want to really understand what are those scanners doing if you are running them, and it's best to really start off with not running those scanners or really running the basic low-level version. For example, let's say Nmap. Most people are familiar with Nmap. You don't want to go T4 on these with scripts and identification and everything. Maybe you want to do an ICMP, maybe nothing at all. And we'll talk about some other methods of without using tools of discovering the network and vulnerabilities and exploits once you're on systems. And then objectives. Like we mentioned before, red teaming is mainly objective driven. So what are your main goals? What are your main objectives that you're trying to accomplish with this assessment? Gain authorized access to the network, gain authorized access to sensitive data maybe, find specific data within your network that your company holds as the holy grail, and then gain maybe into the manufacturing process. So influence the process that's being used to produce something. Some of the attack vectors we're actually going to take a look at here shortly are from the internet. So anybody on the internet, what can they see with your organization? What can they do? Phishing, as well as Wi-Fi and physical. So, yeah, I think this is the last one. Just a quick note about scoping. Scoping is critical in manufacturing. As I mentioned before, there's a lot of systems, a lot of sensitive systems producing a product or doing something that needs to be done. Decides what systems are in scope and out of scope, what kind of attacks and methodologies are in and out of scope, right? You don't want to do a DOS probably, hurt your own organization. You want to come up with a scenario, and most importantly, you want to keep safety in mind. Unlike other networks, maybe that you're penetration testing or red teaming, these can have real physical effects, in the real world. That robot or that machine may do something physically, and in a manufacturing environment, there's a lot going on, right? There's a lot of moving pieces. There's a lot of things moving, and you want to be careful and keep safety in mind. So with that, I'll pass it off to Kyle.
Yeah. Thank you, Johnny. So Johnny already mentioned the 4 attack vectors we're going for. So this is just an example scenario that we came up with from prior research, prior testing. But this scenario is kind of a good overview scenario for what a typical red team assessment could look like. Whoop, didn't mean to go ahead there. Okay, so we're on the internet and we're trying to get into the manufacturing facility. So the first step we do is, now I'm getting dual feedback here. Okay, there we go. The first step we do is we always do internet reconnaissance, right? This is common in every penetration test, in every red team assessment, but it's even more important in manufacturing, which we'll find out why in a minute. But this is a screenshot of Shodan. Have you guys used Shodan? Who's used Shodan? Show of hands. Okay, cool. So everybody's familiar. Most people are familiar with Shodan. Shodan is basically a tool to find devices on the internet that maybe shouldn't be on the internet, or maybe they should be on the internet. In this case, with industrial control systems, sometimes they shouldn't be on the internet. So here we have, use this little magic, I don't want to press any buttons, I don't want to break it. Okay, anyway, so here we have a Shodan search of a, oh, nice, okay. No. Sorry, guys. I'm like a noob. I broke it. Yeah. Where is it? This one here?
Not the middle. Everyone but the one you touched.
Okay. Oh, yeah, right. Yeah. Okay. Well, anyway. Yeah. So pen testing is my experience, not tech support. So yeah, there's a Shodan search of port 102, which is a Siemens port. A Siemens S7 usually uses it, which is a certain kind of programmable logic controller in manufacturing. And here on the right, we see a whole bunch of different Siemens products on the internet. And if you notice something on the left here, some weird operating systems are in place here. We have Windows XP, old versions of Linux, things like this. So these are types of things you want to look for when you're doing your recon on the internet for manufacturing. Sometimes you can find a quick win just from basic internet reconnaissance with Shodan. You can see here on the right, we have some interesting little values. I can just go on my screen. But yeah, we have a lot of Siemens information. We have even a public key right there, which obviously a public key, it's on the internet anyway, but it's just information that you can use to further infiltrate this environment. Another awesome repository is Pastebin and GitHub, also Google dorking, which we can get into later. But Pastebin basically is a public paste repository site where sometimes hackers will paste usernames and credentials on this site. GitHub is another one, a code repository. Things like this are really critical for finding publicly available information that can be used in an attack. In this case, we actually found something kind of cool. This was basically an admin credentials of one of the manufacturing systems engineers on the internet, on Pastebin. And we got lucky here, and we were able to log in to the manufacturing remote access appliance just by plugging in these credentials. So that was pretty cool. And so now, essentially, we have access to the Office IT network. So we can't really do much with this, though, because we just have access to the VPN appliance. We're on the network technically, but we only have access to some of the web servers and things like this. So we want to take it a step further by doing a little bit of phishing. All right. So what we have here is it's a website for, I'm not going to say the company, but it's a website for a common manufacturer of PLCs and HMIs for manufacturing. And in the middle portion here, you can actually publicly access the firmware updates for this product. So essentially what we could do is we could clone this web page and set up a fake repository for updates and firmware updates, patches, things like this. So that's what we did. We cloned the website, and we sent it to one of the systems administrators that worked at the manufacturing facility, and the same one that we found the credentials for online. So we already had a lot of this information, as well as an email address. So we sent this information to the systems administrator. And inside this email was a link to our fake website with a fake update for a fake PLC. So when the systems administrator clicked on our link and downloaded our software, we created a sort of a malware exploit kit to model what an actual adversary that attacks manufacturing networks would do. So we had a recon component, an exploitation component, and a persistence component. Yeah, good talk going on there. You guys should be over there, I guess. Yeah. So basically, all ICS malware will follow this kind of format here. Usually, once the malware executes, they will do some reconnaissance on the environment. This is exactly what Stuxnet did. It looks for operating systems, operating system patches, software that's on the system, things like this. Once we have done some reconnaissance on the system and identified that it's running Windows whatever, we can find an exploitable hole on that system to escalate our privileges and do some other things. So in this case, we were looking for a common Windows SMB exploit. We found it on the system through our reconnaissance methods, and we were able to exploit this Windows XMB hole and establish or escalate our privileges to that of administrator on Windows. After this, we established a persistence method, and this can be done in many ways. Some of the common ways are registry, task scheduler, cron jobs if you're on Linux, things like this. But we basically established a persistent backdoor that we could connect to via our command and control systems on the internet. So now we have internal access to this Office IT network. So. Johnny already mentioned you don't want to, once you're on the network, you don't want to just start scanning and Nmap scanning and Nessus scanning and Nexpo scanning and everything. Basically, you want to be as quiet as possible, not because there's no one, not because people are watching you necessarily, but because you don't want to crash anything. It's very important. Nmap, as Johnny already explained, Nmap will crash a network. Nessus will sometimes crash a manufacturing network. So you just want to do passive techniques, such as Wireshark, TCP dump, things like this. In our case, we just use netstat, like the most basic Windows tool ever. And we found that this systems administrator was actually had an RDP session open to a system on the supervisory network, which was one layer down, and that's one of our target networks. So we were able to log in to this person's RDP session and access this HMI. So this is what a common HMI looks like. Basically, I'll just come over here so I can do this little thing here. Basically, you have so this would be for some kind of a water pump or dam or something like this. We didn't actually include something manufacturing specific. This is more ICS specific here. But this is some of the common things you can do with an HMI, right? You can control the pump, you can control processes, you can shut down processes, start processes, basically just really screw with the manufacturing process. So that's a bad thing. So now, because of this, we essentially own all the network. We were able to get down to the control network, this HMI connected to a robot on the manufacturing plant, and we were able to control the manufacturing process. I will pass it over to Johnny for the next stage.
All right. So the next example attack vector we have is Wi-Fi. And if you can notice, as we're going through these attack vectors, the opportunity of these types of attacks and maybe the impact is less and less, because we started off in the internet that's very wide open to everything. Phishing, now you're on the internet, but you've got to rely on somebody on the other side to have some sort of action take place. Now we're on Wi-Fi. So this example attack vector Wi-Fi requires you to at least be within physical proximity to some Wi-Fi, right? Some sort of signals that you can get. That doesn't necessarily mean you have to be right next to it or you have to be within the building. There's great examples out on a lot of websites of really good Wi-Fi antennas that you can buy, pretty inexpensive to really boost your range from what a normal laptop or desktop, normal cards would have. So for Wi-Fi, you do have to somewhat be within the vicinity. We'll talk about that in a bit. A couple of things, examples you'll see. Within manufacturing environments, within general, manufacturing is on average about like 10 years behind. That's what most of the research says of the normal security cycle. So as an example of that, within this Wi-Fi, you see WEP, you see WPS being used. In most organizations, IT offices, that's not common. You're not connected to WEP. You're not still seeing that being used. There's pretty well awareness about the vulnerabilities associated to that. But within a manufacturing environment, that cycle's a little longer. Maybe that's still being used. Maybe the devices are limited, and that's why that protocol is still being used. That's what those older devices know how to talk to and can talk to. So here you see it, attacking the web. It's succeeding, of course, and then getting access to that Wi-Fi network. This is an example of another passive reconnaissance. Get an idea of what type of network you're on, what kind of devices are there, what can you see from where you're at, where are you? Because when you're red teaming, you don't always have a pretty diagram out there showing you which network you're on, what those IPs are, what devices are on there. You kind of have to do all that on the fly. You have to try to understand where you're at, what do you have access to, what devices are you seeing. And going back to the passive, netstat, Wireshark, dumping information, looking at routes on systems, trying to determine what other systems is this system interacting with, or what other systems are on the network, without actively blasting it with a scanner. So a replay attack, as you can see here, we're on the control network, on the lower network, and we'll show you where this is in the greater diagram right next here. Once you're on that control network, a lot of those devices have trusts kind of inherently built in, maybe because they're older, maybe because that's their model. They're expected to be working on a trusted network. Replay attack is possible with these types of devices. Typically, it's unauthenticated. It's using, passing the protocols across. You can maybe sniff something with Wireshark and replay it and have the same device repeat that same, on-off, or switch something, make it off instead of on, or replay something to make it do the same thing again. That's an example here. So with Wi-Fi, you can see Wi-Fi on the supervisory network. You can see it within the control network. You can have devices connected to it. So with this vector, we've essentially, it's possible to get supervisory network, control network, but maybe not get the office IT network. If you're red teaming and you're objective driven, maybe the office IT was never an objective anyway. You're trying to get to the control network. And with this attack vector, you can get straight to the control network without making all the noise and detection capabilities that are on the office network that may not be on the control network.
I forgot one thing I was going to say.
Yeah.
Sorry, guys. Sorry, Johnny, interrupt. So why it's very important to look at Wi-Fi on the network, on the manufacturing networks, is because, as you can see, the Wi-Fi is kind of off to the side here on the supervisory and control network. So we could actually, in some cases, potentially access Wi-Fi outside of the plant itself. So basically, if we have a plant wall or something around our plant, or plant fence or whatever, we could actually access the Wi-Fi outside of the plant. So this is why it's very important to look at Wi-Fi. Just wanted to say that.
Yep, and we'll bring that up in mitigation measures also, how to use the proper antennas on your Wi-Fi if you are using them directional versus, spreading out to everybody in all directions. The last attack vector is the physical. We have an example there of a security fail. So, you put up a gate, you put up a door, great, but there's no fence, supporting it. People can just walk around, kill those brushes. Physicals, as we're going down again, less opportunity here. You have to physically be there within the manufacturing environment. You have to interact with other humans, unfortunately. And a lot of the same social engineering techniques that you've seen otherwise would work here too. Fake ID with a bit of nice talking, hey, how's it going? Great weather, whatever you want to say. Get access, look like you belong, play nice. Or you can go the other route, look official, look like you're somewhere higher up where they shouldn't talk to you or something like that, that works too. Oftentimes within these assessments, there's vulnerabilities everywhere, right? But humans are typically the biggest weakness. Saw that with the example of phishing. They're going to click something if they think they're going to, if it looks right, or if you entice them with something shiny, they may click it. You may get them that way. Humans are more unpredictable than machines, so typically they're the biggest weakness in the link. And again, the main concern here is safety. So in a manufacturing environment, you have those big robots doing things. You don't want to be caught on the wrong side of those things. If you are physically assessing a system, you want to take a look at what you're doing, what you're going to get access to, what kind of position that'll put you in once you're in there. You don't want to be in a bad position for your own safety. And this is just an example of what you can get access to, right? So bypassing all the control go straight to the control network, bypass the office IT network, and you have physical access to physical buttons and can either change processes or manipulate things that way, turn things on, turn things off, or in a lot of times, you can implant something. So implant maybe something as a C2 command and control to give network access to you, walk out of there, now you have network access, you can go home and work from the internet. So a lot of potential for physical, it just requires that you're actually there, and there's greater chance you're seen, et cetera, et cetera. So with the physical, you can get straight access into the control network. Maybe once you get past the perimeter, just go into the manufacturing side. You're assessing the controls on the perimeter as well. Are they looking at badges? Do they care? Do those badges scan? Do they care if they scan? What kind of policies and procedures do they have in place for somebody that's unknown? Did they follow those? And that's the kind of thing you're looking at when you're red teaming on the physical side. So maybe they have all these processes and policies in place, but you find out when you do this, maybe they're not following them. Maybe a nice wave and a hello, good morning works, right? Maybe if you look trustworthy enough, that's all that matters. So worst case scenario, as you're doing this red team assessment, you got to figure out what's the worst case scenario. You got to kind of brainstorm in your mind what's the worst thing that can happen from you doing it and also attackers. So is denial of service, is shutting down the manufacturing system the worst case scenario? Is that going to affect the bottom line? Send commands to process, manipulating the process in some way and that way not being detected. Is that a worst case scenario? Or getting the sensitive information out of that facility. Is it proprietary and you just want the information so you take it and go use it somewhere else or sell it. So there's endless opportunities. A couple things here on the right we want to show is the attacker objectives. So loss, denial, manipulation. Can you manipulate the processes without a defensive measure kicking in or taking notice? Can you deny things happening on the network, stop network traffic, deny things, or loss of control of the network? Yep.
Yeah. So some of the lessons learned we learned from our experiences in red team manufacturing. So manufacturing networks are using very outdated software, hardware, protocols, things like this. This is a common issue in I think all of IT security, but it's very prevalent in manufacturing environments. I mean, we see XP running, very old protocols like WEP, things like this. So it's important to be safe when you're red teaming manufacturing environments. So don't bring anything down. No denial of service attacks, things like this. But it's just an important thing to mention that these networks are usually very old. Some of the old attacker techniques still work against these networks, like the WPS Wi-Fi Pixie attack that cracks WPS protocol. And things like this, web attacks, just attacks like these, old attacks that we haven't used in, like Johnny said, we haven't used in 10 years, still work against these networks. And then last but not least, use vulnerability scanners very scarcely. So even Nmap, I would advise not even to use that. Just passively listening on these networks is the best way to go about it. So using Wireshark or TCP, things like Responder definitely probably is a no-go. But passive listening techniques are the best way to learn about the network. And some of the common findings that we discovered. Whoops, Johnny, I dropped your clicker in this little hole here. You're not getting that back. So some of the common findings we have in manufacturing. This actually, we pulled this from the DHS common vulnerabilities in manufacturing. But this is also true to what we found from our various research. So the first one would be authentication and access control. There's just a lack of authentication for some of these older manufacturing protocols. Like we could intercept communications and see clear text passwords, clear text commands, things like this. We were able to replay attacks very easily with no authentication needed. And of course, access control. A lot of default credentials were in place. For example, on the VPN appliance, two-factor wasn't enabled. Just some things that we would consider basic in IT security is not necessarily on the manufacturing network or not enabled. The next would be network design. This goes into network segmentation and segregation. There were a lack of segmentation between different networks. For example, the supervisory and the control network should always have some kind of a segmentation or a firewall in between, and we sometimes didn't see this. Another thing about network design is networks were not very well documented, so the IT staff really didn't know, and the security staff sometimes didn't know what was on the network and how the network was laid out, and there was no formal documentation for this. Policy was another big one. Sometimes there weren't any. There should be some policies governing, basically security governance. There should be some policies governing different aspects of manufacturing security. Monitoring. If there was monitoring going on these networks, sometimes nobody was watching the screen, so that's a problem. Obviously, if you're going to have monitoring, someone should be looking through these logs and finding us, because we were able to do a lot of these attacks in our example scenario, especially without anyone actually seeing what we were doing until after the fact. Configuration and maintenance. This would be general asset management, so basically know your assets. This would involve doing a asset inventory of your manufacturing facilities and ICS environments, and really knowing what's on your network, what software, what hardware, basically knowing your network inside and out. And this goes along with also patching and maintenance. So patching is difficult in IT security, but also in manufacturing facilities. A lot of this hardware and software is very dependable. It's built for reliability and not for security. So it's difficult. It's difficult to patch these things. But the first step is asset management and knowing what's in your environments. And finally, security awareness. So this is also a problem everywhere. But one thing that we've noticed is usually the manufacturing floor, like the people actually working on the manufacturing environments and the robots themselves, they may not have any idea of what security is. So it's important to train these employees and so they understand that if someone strange is walking around the environment, unplugging things in their network and things, to kind of question them and say, hey, what's going on? Okay, next slide. Thanks, Johnny. So some of the mitigating measures. We have safety or security awareness training, which I just mentioned, train your staff. Strong remote access policies, so this would be along the lines of strong VPN policies, configurations, enabling two-factor, expiring accounts that should be expired, things like this. Proper network segmentation, which I already covered. This would be installing firewalls where they need to be installed, and ensuring each level of the network has a separate separation and segmentation policy. And auditing of the Wi-Fi configurations. So make sure you're not using WEP, make sure WPS is off, things like this. And then asset management, which I already covered. This kind of covers the entire network, but just really know your environment, know your assets, your software, your hardware, your robots, what needs to be updated and when. And this is really the first step to proper updates and securing the environment. And then we have, monitoring, of course. This would be, which I already covered, basically monitor the environment for anomalies, monitor the environment for attackers, so that you can catch, the red team, you can catch us on your manufacturing network. Sorry, guys, I don't have the clicker, so. Regular patching, which I covered, and finally, make sure to do regular security assessments and red team assessments, penetration testing, audits. These techniques really help you understand your risk in your environment. So we'll cover this in the next slide, but it's very important to know your greatest risks because, right, in IT security, everything's a risk, everything's critical. But really, this is a great method, especially red teaming is a great method of finding your critical risks in the environment and what you need to fix first. So one thing I want to say is it's very easy for us to stand up here and say how bad manufacturing facility security is and how awesome we are, what great red teamers we are, and how we pwned your network. But blue teaming is much harder, I'll admit. And so it's very important to know your risks. And this is the main thing that we want to get across here. Just know your most risky parts of your network. So complete a risk assessment. This is, I would say, the first step in securing your environments and know your assets. Perform a security assessment or a red team assessment and find out what is the greatest risk to you and your environment. And this can be done with using the example red team methodology we have here, kind of picking based on your threat model, pick a type of attack that you would want to perform on your manufacturing networks and really determine your greatest risk this way. And finally, create a plan to start mitigating these risks. So pick your top 3 and create a plan to start remediating these. So an example would be, begin taking inventory of your assets, asset management, audit your current access controls and your current access control policies, and finally, implement a strong network segmentation. So these are just 3 things that we think could be quick wins for you in your environments, but it could be anything. Just it's really facility specific. You go to the next slide.
Yeah, I'll just add to that. Like you said, it's easy for us to say this was broken, but on the flip side, it's very hard to secure these types of environments and really get them up to the same par as maybe some of the other side of the IT world. Their life cycle is longer. They have a real need. They need to be up 24/7 most of the time. They're doing a job that must be done, can't be interrupted. So that brings about challenges on its own. So we just wanted to highlight here that it's easy for us to say this and this and this is broken, but we realize it's also hard for the defenders that are monitoring the network or the system administrators that are trying to make their network secure here on these manufacturing environments. And we're trying to just point some quick wins like Kyle said.
So these are some of the resources we used in our presentation here. So these are all awesome. This is why we included these, and sure, take pictures of it. These are, especially DHS, Industrial Control Systems manual here. The DHS Common Cybersecurity Practices, this is good. My favorite is the Industrial Control Systems Cybersecurity Kill Chain. This is awesome. But these are just really good documents you can use to start with this with security assessments in your environments.
Yep, and this is just a few. There's a lot that, on both sides of this, there's a lot to dive into red teaming and how to do that efficiently. There's a lot that dive into the industrial security side and how to do that efficiently. So we thought we'd provide some to get you started and get you down the right path. But there's a lot of resources out there that are good. And with that, we'll end. We'll open up to questions. Hopefully we'll have answers.
You mentioned in your assessments or in your assessment plan that you're not going to do a DOS, but from the standpoint of the internet, is that not a realistic scenario?
Want to take it?
Yeah, I can do it. Go for it. Yeah, so it's a very realistic scenario, but we also care about our manufacturing facilities. And if we bring it down, that's money,
Yeah, that's the downside of being, let's say, a red teamer or penetration tester. You have to find the vulnerabilities, but you also have to do it in an effective way and not have, a negative impact on the organization you're testing. On the flip side of that, on the internet, there's probably attackers doing that all the time. But specifically for DOS, we're talking about control network, supervisory network, where that's, has more of a greater impact. And those typically, well, sometimes they're available on the internet, but most typically they're not.
Good question.
Yeah.
I think just last month you heard about Tesla, General Motors. They didn't attack you, but they attacked one of your third parties and got manufacturing specs, the tolerances you put on your machines. Do you see any change, especially from General Motors, of maybe doing a little bit more to third-party vendors? Because obviously, if you're doing a good job protecting, but all your information is sitting on third party and gets owned and dumped, then how does that influence with your red team actions, maybe with third parties or vendors?
Right, so good question. I don't have the most up-to-date information on that. I will say, like you mentioned, it was a third party. I'm on the General Motors side. I wouldn't have the most up-to-date information on that, but I could probably get you a better answer later.
Or do you mean like mainly the techniques, or how that actual attack affected?
I was wondering, especially, obviously you're protecting your information, but instead of attacking you, they attack the third party. You still have the same thing, manufacturing specs, your tolerances on your machines, how your machines better, even the machines you were using. Obviously they can tell that from if you get what your actual manufacturing lines are. I'm just wondering if obviously they attack them instead of you, but how does it affect you? You think that maybe the bigger companies, maybe General Motors, should be doing something more to test the security of their third party when it has the same data that you're trying to protect also?
Right, yep, I understand your point. That's the difficult part. Third parties may have some data that's related to us. Unfortunately, I don't have more information on that. But I can talk to you after this and try to get you a better answer.
How often do these teams have development or test systems that you might be able to run more intensive scans on without, taking down production?
Right, and that could go back to scoping. So it could be that the manufacturing organization would like to know, instead of a red team assessment, what are all the vulnerabilities associated to this box, right? So they set up that, and your scope is, well, let's just take a look at this box and see what's going to happen here. So you can definitely scope out an assessment that way, although it won't be as useful. But like we said, there's multiple layers to do here, and that may be one step in a greater assessment later on in the future of taking a look at a example manufacturing device, like you mentioned, and just using that scope and throwing everything at it, seeing what's available, and giving them that.
So it sounds like nobody's really asking for that scope.
Well, that would be very specific. So a scope of here's one box, take it down, that type of thing, or find everything wrong with it. That falls more into penetration testing. So we have done that, but that would be a penetration test. The red teaming is more of objective-driven. Use anything you can to get to that objective.
So a question I have is not all of us will have manufacturing systems, but a lot of us probably have SCADA systems. Is there anything that you would change or do when approaching this from a SCADA perspective?
Right, so that's a great question. That's why in our beginning of the terms, we try to level set with ICS. That's our all-encompassing term of SCADA, PCS, all the acronyms that go under it. Most of the references we showed you here would be applicable to SCADA also. That's just a subset of ICS. So we generalized and called it ICS, but most of this would be applicable to SCADA. Yeah. And a lot of the mitigation measures are also the same, right? So defense in depth, are you doing user awareness? Do you have policies in place? Are you looking at your access logs? Do you have access logs? So a lot of the defense in depth mitigation measures would be the same, and a lot of the attacking of that network would be similar.
Hey, thanks for the presentation. You guys mentioned a few times shying away from active scanning on the network because it can have adverse conditions on the equipment, and you suggested using just passive monitoring of the environment using Wireshark or TCP dump or whatever else as a way to get the information that you want. How do you deal with the amount of data that you collect, and how do you derive interesting findings from that traffic? Are there any specific tools or techniques that you use to dig through, gigabytes of PCAPs and to find the juicy stuff that's otherwise given on a silver platter and on an SSCAN?
Yeah, so let's see. I would say Wireshark has been the primary tool, but Wireshark has a lot of awesome plugins for ICS and for manufacturing. I would say there's a plugin for most protocols in manufacturing and ICS. So one of the common things to do is to use the Wireshark search tool and search for certain strings, certain protocols. For example, maybe I'm trying to do, so if I was doing like a reconnaissance with a Wireshark, I would search for ARP or something like that to try to find what system is talking to another system through layer 2. Things like this. I would look for HTTP connections, outbound, things like this. Yeah.
Yep, so I'll add to that. One, I think what you're shooting for here is, so let's say you do use Wireshark and you're creating all these manual search terms and trying to dig through it. There are also open source software out there that will take a PCAP and do all that parsing for you. And then you just go through and look at the interesting results. So example of that would be Netminer. That will take a large PCAP, you feed it in, it'll say here are what we think are clear text credentials, here's what we think is this type of traffic. So that's one way to go through that sort of data very quickly. But it's up to you eventually as the red teamer, as the assessor, to look at that data, try to get the meaningful information out of it, and then choose the actionable data to keep moving on. Yep.
Hi, I'm just kind of curious from the remediation perspective a little bit in terms of one, how much traction have you gotten? Also, has there been any pushback in terms of some of the recommendations on what needs to be fixed? How is that prioritized? And who is the ultimate customer? I hope that helps.
Let me take a shot, then you shoot a shot? Okay, so there was a lot of questions there. Let me try to remember them all. So we have found that doing a red team assessment is much more impactful to, say, the customer, whoever we're doing it for, whatever organization, because they'll see the real results, right? So a lot of times they get handed a security assessment and it's a scanner results, right? So you have this vulnerability and this one, and it's hard for them to interpret what that means. What is the real risk here? What does that actually mean? But when you do a red team assessment, it's much easier to drive that impact home by saying, here's all the plans to product X we took last week that you didn't find, right? Or you didn't see us. So that really helps really drive home the impact of the vulnerabilities, and that usually gets their ear, and they start to pay more attention because they see what's a tangible result out of having these vulnerabilities there, versus a scanner that may just say it's a medium risk to have this vulnerability. That's much less tangible. I think there was a second question there on. Could you remind me? Typically, it's more of a helpful atmosphere. Maybe at first there's some, back and forth on what took place. They usually want to know what happened. And as we mentioned in scoping, maybe not all of the employees within the organization know what's happening. So that's to be, expected. But once we get pushed past that and show the results, usually it's how can we fix this? What do you think is the best route to continue? Okay. What? I think.
Sorry, I'm trying to figure out what they're trying to.
Sorry, they're trying to disappear. Yes. Oh, I think successful in fixing. Definitely, yes. A lot of these, as Kyle mentioned, are low-hanging fruit. As soon as you're aware of them, it's much easier to drive the remediation to fix them. Maybe it's configuration change that doesn't take much time. But some of the other ones are more long-term. How do we fix the environment? How do we fix the network? What can we do with next generation? Or how do we fix that next year? So there's always planning involved.
Yeah, and one more topic, one more point on that. I can't speak for any company, right? GM or my company. But from my experience, people are very willing to work with us because a lot of these manufacturing plants don't necessarily have a security staff, right? And they're just learning how IT security is so important from the news and things. So they're very willing to work with us, from my experience.
So kind of along the same lines, you guys are talking about culture and working with people and on their systems. Have you guys handled the culture of this is my system and my stuff? And even to take it a step further, if you broke something, how did you handle that?
I mean, we have broke something.
I've definitely broke something.
Yeah. So this is I think we're out of time. This is a kind of a loaded question. I really want to talk about this. So if you could come see us afterwards, that would be awesome. Yeah. 2 minutes?
2 minutes.
2 minutes. Can we tell a story about how he broke something? I don't know. My boss is in the audience. I'm not going to, or my old boss. I'm not going to say who it is, but can I?
No, I'll say something. All right. So to your first question, I mean, yes, I have broke something. It was intended. It was to show an example similar to what you mentioned. Here's a box. What's the real vulnerability? What can we do? So your first question was, how did they push back on that, right? So like I said earlier, sometimes there is initial pushback because some of these red team assessments may not be knowledge to all employees. So if it affects, let's say, a particular sysadmin who really thinks they're doing a good job with their system specifically, they may be defensive on what vulnerability was found where and why that was. Like, oh, I'm about to fix that. You shouldn't be there. But once you kind of explain the situation and usually provide the information and know that we're not targeting a person, we're looking at the environment as a whole. It's not whether this system was vulnerable. It's how is the network or how is the system as a whole interacting with each other and the ways we exploited it. So that's one thing. Make sure that we don't target specific people or services or processes that we're trying to convey at the entire environment. And that can help mitigate some of that finger pointing. And then again, once they see the impact of these vulnerabilities, sometimes they're more receptive on, okay, I want to fix this. How do I fix this?
Quick last remaining question. We still have maybe a minute or two. Okay, well, thank you guys so much.
Thanks, everyone.